Welcome to this explainer. I am absolutely thrilled to have you here today, because we're tackling something that is literally the lifeblood of any aspiring ethical hacker or security analyst. We're mastering the command line interface, the CLI, in Kali Linux. We're stripping away all those flashy, resource-heavy graphics and getting right down to the bare metal of the operating system's POSIX architecture. You know, if you want to truly command a system, you've got to speak its native language. And that is exactly what we're jumping into today.
Okay, here's our execution plan for today. We're going to hit the command line gateway, navigate the file system, do a little file manipulation, check out standard streams and pipes, and then wrap it all up with a hands-on bootstrapping exercise.
Number 1, the command line gateway. Basically, bypassing the GUI.
So, here's a question for you. Why on earth would a hacker prefer staring at a simple blinking text box over a gorgeous, highly designed visual interface? Like, why leave the comfort of just pointing and clicking your mouse?
Well, the answer boils down to one thing: raw, unadulterated power. The CLI is your ultimate master key. By typing commands into a shell, you are speaking directly to the OS kernel. There's no waiting for heavy graphics to load or abstraction layers to process. You're executing tools at lightning speed, running automation scripts, and directly manipulating memory and processes. It's just you and the machine. Total control.
And this right here, this is what that gateway actually looks like. It might look super simple, right? Just a string of text ending in a $sign? But man, this is where the magic happens. This terminal prompt is your direct, unabstracted assistant. It tells you exactly who you're logged in as, what machine you're on, and it just sits there, patiently waiting for you to feed commands into your shell, which is usually going to be bash or ZSH in Kali Linux. Moving right along to section 2, navigating the file system. Let's learn how to actually walk around inside this new virtual space. Okay, if you remember only one thing today, make it this. Linux treats absolutely everything as a file. It's a total paradigm shift. If you're coming from Windows, you're used to seeing a C drive, a D drive, maybe an E drive when you plug in a USB. Well, Linux doesn't do that. Instead of scattering things across multiple disk drives, Linux merges the whole shebang, your documents, your hardware, your network sockets, into one single massive virtual directory. And this massive directory is laid out like a giant hierarchical tree structure. It's dictated by what's called the File System Hierarchy Standard. But the coolest part? It all starts from a single point at the very top. We call it the root directory, and it's represented by just a single /. Literally everything you interact with branches out and down from that one single root. Because it's structured like a tree, you basically have two ways to tell the system where something is. You can use an absolute path, which gives the full exact address, starting all the way from that root /. It's kind of like giving someone exact GPS coordinates. Or you can use a relative path. That's giving directions based on where you currently are in the tree, like saying, hey, go 2 doors down. Now, to actually move around and map your surroundings, you're going to rely on 3 foundational binaries. Think of these as your eyes and legs. First up is PWD, or Print Working Directory. That tells you exactly where you are right now. Next is LS, which lists the contents of your folder. A quick pro tip for you. If you add the -LA flag, you'll actually see all the hidden .files, like your bashrc, plus the exact permission matrix. And finally, CD, or Change Directory, which is what you use to actually move from one folder to another using those paths we just talked about. All right, section 3, file manipulation. It's time to start interacting with and altering things in the environment. You literally have the power to create, relocate, or destructively wipe files with just a few keystrokes. mkdir builds new directories. Touch creates brand new empty files out of thin air. You can duplicate stuff with cp for copy, or move it around with mv, which actually doubles as your rename command. Oh, and if you need to alter a file's security state, you've got chmod to change permissions and chon to change who owns it. And when it's time to wipe something off the face of the earth, you use rm to remove it. But seriously, be careful with that one. If you force a recursive deletion by typing rm-rf, it completely bypasses the safety prompts. So handle with care. Section 4, standard streams and pipes. This is where it gets really fun. Think of the command line as this giant plumbing system, and we're about to become the master plumbers. To understand this plumbing, we got to talk about standard streams. Simply put, these are the invisible pre-connected communication channels that funnel data in and out of your terminal apps. Every single time you run a command, these streams are silently opening up in the background, ready to route your information.
Let's break down how this data actually flows. There are 3 default streams always open. Descriptor 0 is standard input, or STDIN. That's usually taking data straight from your keyboard. Descriptor 1 is standard output, STDOUT, which takes the results of your command and prints it right to your screen. And then descriptor 2 is standard error, STDERR. This one is super clever. It's a separate diagnostic channel dedicated purely to error messages so they don't get all jumbled up with your normal successful output.
But here's the kicker. You aren't stuck just using your keyboard and screen. You can use redirection operators to act like physical valves on these pipes. A single greater than sign takes your output and overwrites a file with it. A double greater than sign safely appends your data to the end of an existing file. You can even isolate just your errors by using a to and a greater than sign to funnel them into a separate error log. You are the one in total control of where the data goes.
And that brings us to my absolute favorite tool in the kit, the pipe. It's symbolized by that little vertical bar on your keyboard. What it does is take the standard output of the command on the left and funnels it directly into the standard input of the command on the right. It's incredible. You can just chain tool after tool together, creating these really powerful custom data processing pipelines right on the fly. It is a total game changer.
Which brings us to section 5, hands-on bootstrapping. It's time to pull everything we've talked about together into a real, practical implementation. Here is our execution plan. Step 1, we're going to initialize a secure workspace. Step 2, we'll generate some mock network data and wrangle those streams. And step 3, we'll parse and interrogate that data using a custom pipeline. Ready? Let's do this. Step 1, initialize. We're going to type mkdir-p and then a path, like your desktop/cyberlab/target logs, to create a nice nested folder structure. Then, we just cd into that exact path to change our context and step right into our fresh new workspace. It's simple, fast, and super efficient.
Step 2. Generate data and handle the streams. We use the echo command to spit out a string of text representing, say, a suspicious IP address attempting an unauthorized access. But instead of just letting it print uselessly to the screen, we use that single greater than operator to funnel that standard output directly into a newly created file called rawlogs.txt. You know, you could even follow that up with a double greater than to append a successful login, or use 2 greater than to route any firewall drop packets out of your main log entirely.
Step 3. Parse and interrogate. This is the payoff. We cat our log file to read it, and then pipe it straight into Grep to filter for the word unauthorized. Then, we pipe that result straight into WC-L to count the exact number of malicious hits. Boom! Pipeline magic. And then for the lockdown phase, we use Octal notation, typing chmod 600 on our alerts file. That strips away the permissions so that only the owner can read or write to it. Just like that, you're doing seamless, rapid security analysis, all from the keyboard.
So, think about what we just did. You now understand the POSIX architecture, the file navigation, and the data flows. You've completely bypassed the GUI and unlocked the gateway directly to the Linux kernel. The only question left is, what will you command it to do next? Thank you so much for joining me on this explainer, and I absolutely cannot wait to see you in Module 4, where we take these skills to the very next level.